Section 5 of Scientific American Supplement, number 415, December 15th, 1883. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in March 2022. Scientific American Supplement, number 415, December 15th, 1883, by Various. The Manufacture and Characteristics of Photographic Lenses. At a recent meeting of the London and Provincial Photographic Association, Mr. J. Trail Taylor, formerly of New York, commenced his lecture by referring to the functions of lenses, and by describing the method by which the necessary curves were computed in order to obtain a definite focal length. The varieties of optical glass were next discussed, and specimens, both in the rough and partly shaped state, were handed round for examination. The defects frequently met with in glass, such as striae and tears, were then treated upon. Specimens of lenses defective from this cause were submitted to inspection, and the mode of searching for such flaws described. Tools for grinding and polishing lenses of various curvatures were exhibited, together with a collection of glass discs obtained from the factory of Messrs. Ross and Co., and in various stages of manufacture, from the first rough slab to the surface of highest polish. Details of polishing and edging were gone into, and a series of the various grades of emery used in the processes was shown. The lecturer then, by means of diagrams which he placed upon the blackboard, showed the forms of various makes of photographic lenses, and explained the influence of particular constructions in producing certain results, positive and negative spherical aberration, and the manner in which they are made to balance each other, was also described by the aid of diagrams, as was also chromatic aberration. He next spoke of the question of optical center of lenses, and said that that was not, as had been hitherto generally supposed, the true place from which to measure the focus of a lens or combination. This place was a point very near the optical center, and was known as the Gauss point, from the name of the eminent German mathematician who had investigated and made known its properties, the knowledge of which was of the greatest importance in the construction of lenses. A diagram was drawn to show the manner of ascertaining the two Gauss points of a biconvex lens, and a sheet exhibited in which the various kinds of lenses, with their optical centers and Gauss points, were shown. For this drawing he, Mr. Taylor, said he was indebted to Dr. Hugo Schröder, now with the firm of Ross and Co. The lecturer congratulated the newly proposed member of the Society, Mr. John Stewart, for his enterprise in securing for this country a man of such profound acquirements. The subject of distortion was next treated of, and the manner in which the idea of a non-distorting doublet could be evolved from a single biconvex lens by division into two plano-convex lenses with a central diaphragm was shown. The influence of density of glass was illustrated by a description of the doublet of Steinheil, the parent of the large family of rapid doublets now known under various names. The effect of thickness of lenses was shown by a diagram of the ingenious method of Mr. F. Wenham, who had long ago by this means corrected spherical aberration in microscopic objective. The construction of portrait lenses was next gone into, the influence of the negative element of the back lens being especially noted. A method was then referred to of making a rapid portrait lens cover a very large angle by pivoting at its optical center and traversing the plate in the manner of the pantoscopic camera. The lecturer concluded by requesting a careful examination of the valuable exhibits upon the table, kindly lent for the occasion by Messrs. Ross and Co. End of section 5.